Compound interest. Let's say we have a $1,000 investment and a 10% interest rate. If this were simple interest, we would just take our $1,000 and we would just add to that our interest, which is just going to be 10% of 1,000. So that would be 100. And then our new value would be 1,100. And when it came around for interest again, we would just add another 100. And now it would be 1,200. But in compound interest, we would take our $1,000 and then add our 10%, and we would get 1,100. But instead of adding 100 again, we would take 10% of our new number, 1,100. 10% of that would be 110. So now we would have $1,210. So here you are earning interest on top of interest. So this is what we call exponential growth. Exponential growth. So in compound interest, your money is going to increase exponentially. In simple interest, this is going to be a linear rate. It's going to increase at a constant rate. But in compound interest, the rate is ever increasing. So now let's look at a graph to compare simple versus compound interest. So I have two graphs here. The blue one is simple interest and the orange one is compound interest. The initial investment here was $100, and in both of the graphs, the interest rate is 2%. And you can see how much faster the compound interest grows. You can see the simple interest is just a straight line, but here the compound interest is exponential and grows rapidly. If we look at 50 years here, let's say this $100 was growing for 50 years. You can see in simple interest you would have $200. But if you go up here to compound interest, you would have $269. That is a big difference. So now that we've gone over the basics of this, let's talk formulas. Let's say you want to know the total amount of money made with compound interest. We use an A just like in simple interest, and this formula is going to be our principal multiplied by 1 plus our rate divided by n, and then we raise this to the n times t power. So the formula for the total amount of money in compound interest would be A is equal to the principal times 1 plus r divided by n raised to the n times t. So let's break this formula down. P is going to be our principal, which is our initial investment. And then this part, 1 plus r divided by n. R is going to be our annual interest rate. Now it has to be annual because n is going to be the number of times it is compounded in 1 year. Because compound interest doesn't just have to add interest annually. It can also be compounded monthly, weekly, daily, or even continuously. We'll look at that later because that's a different formula. So n is going to be number of times compounded. And then t is going to be time, but it has to be in years. So to look at this further, our annual interest rate is being divided by the number of times compounded. So instead of, let's say if you had a 4% annual interest rate and it was compounded quarterly, you would have your 4% rate. But remember, our interest rate has to be a percentage written as a decimal. So this would actually be 0.04. But I'm just going to write it as 4 just for simplicity right now. So number of times compounded. If it's compounded quarterly, that's going to be 4 times. So our rate is going to be 1%. So instead of being compounded 4% annually, it is compounded 1% quarterly. So it's compounded 1% 4 times every year. And that's important because compound interest is exponential. So if you compound it more times in a year, you're getting more money. In simple interest, if your interest was paid out multiple times a year, it wouldn't actually change how much money you made. But in compound interest, it does, so we have to include it in our formula. So that's why our time has to be in years, and then we multiply that by n, and we get the total number of times compounded over the time period, and then we raise our equation to that because it is exponential. So if we wanted to know just the interest that we made and not the total amount of money we'd have, we would take our original equation here and then subtract our principal. So we'd get the total amount of money and then subtract our initial investment, and that would be how much money we made. That would be our interest. But remember I said there is another formula. Compound interest can be compounded continuously, which means instead of having a set time it is compounded, it is always being compounded. So let's look at the formula for that. A is going to be equal to principal times e raised to the r times t. So again, t is our time in years, r is our rate as a decimal, p is our principal, which is our initial investment, and then e is the natural number e. It should be on your calculator as just an e, or the inverse of the log function. But e is approximately like 2.61, I think. So if we're compounding continuously, which is how you would make the most money, then we would use this equation here. So now let's look at some graphs to compare continuous compounding, annually, and monthly. This is going to be a little hard to see because these lines are very close. So here in orange we have it compounded annually, in purple it is compounded monthly, and in green it is compounded continuously. So let's zoom in. Let's go a little farther down the line, here like 5 years, and then scroll in a bunch, just to be able to see. And you can see here that when it is compounded continuously, it has the steepest growth rate. When it's compounded monthly, it is slightly less steep, and then annually is much less steep. So the money will grow the fastest when it is compounded continuously, and the more it is compounded, the faster it'll grow. And that is it for compound interest. I will make another video solving some example problems so we can actually use these formulas, and I'll put the link to that into the description.